Okay, let's start with the everyday language. If you said I'm tolerating something, that means you put up with something, right? Or someone. You're putting up, but there's a certain degree where you wouldn't allow it anymore, right? If somebody's if someone is too controlling, you're like, hey, we're done, right? You break off that relationship to controlling. It's not good. It's unhealthy, right? Uh, and it could be, right, Mr. Dirkson's tolerance for lates, right? There's a certain point where I kind of get a little cranky, right? Like if you're always late, I'm like, hey, seriously, what's happening, right? Um, so for a lot of us, it's on the high side that we don't tolerate if it gets to a certain high. But there's also tolerance on the low end, right? Uh, so my perfect example for the low end is a runway for an airstrip, right? Where planes land. It can't be too short, right? If it's too short, then there's a problem, right? The plane may run out of runway, and then that's a safety hazard, right? So you'd be okay with it being longer, but not shorter, right? And so we're going to apply the tolerance. We're going to have a specific definition for it, but it is sort of the same as what you would use it in everyday language. But we have a bit more of a stricter definition. There's a line, and we don't cross it, right? So here we go. In manufacturing, the dimensions of the product may vary. So when you work at a, right, I used to work at Kitchen Craft. That's always my go-to. We did a lot of this. We did applied a lot of this. If I ripped this piece of wood and I measured it, I would actually have this all the time on me. Caliper. This one died, but there would be a digital display here, and I would take that piece and measure it all the time. I would have to constantly measure, because if I rip this piece if it's too narrow, the assembly line down the line, they would complain because they would machine it and they're like, hey, we can't do the profile on this piece because it's too narrow. What did you do, right? And so we would be in big trouble if you didn't check all the time. There's thousands of dollars of material that you now wasted, right? Never mind the labor that went into it. So we had a tolerance on the low end, and we also had a tolerance on the high end. So that's basically tolerance, right? It could be narrow, but not too narrow. It could be wide, but not too wide, right? And that is for various reasons, right? It's due to various factors. There could be an operator error. It could be faulty equipment. Sometimes my blades, sometimes when I ripped lumber, there were bullets in there from people hunting in the forest, and it was in the piece of wood. And I would just see a spark go in my machine. It's like, no way, right? So it was a piece of a bullet stuck, so that ruined my blades. I had to go and get them sharpened or replace them, keep going, right? But that affected your rep big time. Limitations on the measuring device, the temperature, right? Sometimes the wood was frozen when it was just delivered. It was like we had to kind of let it get to the room temperature, otherwise it would be affected, right? And so that's the case on almost any industry, right? Companies or businesses would lose a lot of money if they would only accept parts that match the target value, right? This is very important. You would lose a lot of money if you only accepted the actual target. Hey, I want this to be 45 millimeters. It's not garbage. They would lose tons of money. You can't do it that way. Okay. That is why most, if not all industries, allow for some variation, right? You allow for some variation so that the part can still be used for its intended purpose. That is very important too. The part can still be used for its intended purpose. Depending on the industry, the tolerance may be a greater, smaller, or greater, right? Depends on the industry. I would say that also depends on what stage of the process you're in. If you're way up the stream of the process, there's more leeway, but as you get closer to the finished product, you need to be closer to the actual measurement. But you don't need to worry about that too much. Here it is, guys. Tolerance is the range of acceptable measurements. It can also be described as the variation allowed so that the item is still acceptable for its intended purpose. I'm kind of repeating myself there. But this is probably worth boxing in. And I would also say that make sure you know what precision is. Make sure you know what uncertainty is. And this is the last one, tolerance. Make sure you know, because I do multiple choice on those quite often, or fill in the blank. And you can often use your own words, but you just got to know what does it actually mean. Let's say a company assembles doors for houses. I'm going to use a different color here. Maybe I'll just go orange again. If a door is too small, there'll be a large gap, right? If the door, if you're installing a door and you can see light coming through the cracks, that's a bad install, right? It's too big, right? It will allow warm air to escape and cold air to enter the home. So that's the problem with it being too small. If it's too large, the door would just not fit inside the frame, right? This is basically, guys, the concept of tolerance in words, okay? You can't have it too small, you can't have it too large, right? The door would either not close properly or it would be very difficult to open or close. I don't know if you have doors at your home or if you ever encountered where you have to like almost rip out your arm to get that door to open in the winter. It might be too tight of a fit, right? Some more definitions, okay? The tolerance would have been in between the two scenarios above, right? So the tolerance is what we allow in between here. So here is the difference. I always had students tell me, well, what's uncertainty and what's tolerance? Because there seemed to be some overlap, okay? So here it is. I kind of made this chart for you. Uncertainty is determined by the measuring device. It's the margin of error. It's set by the measuring device that you used. That's what uncertainty is. It's because of the limitations of the device. I will say this. Due to limitations of measuring device or devices, right? Maybe there have been a couple used and that's what causes the uncertainty. Tolerance, however, I'm going to use orange here to kind of, tolerance, however, who determines the tolerance? Who determines what's acceptable? It's the industry. It's set by the industry, right? It's determined by the industry. I'm saying it 2 times, right? And it would be the range of acceptable values so that the thing can still be used for its purpose. Right? That's what tolerance is. It's set by the industry. It's caused by human error, equipment malfunction, limitation of measuring device, which is the precision, right? So tolerance is, if this is the max and this is the min, this is what we call tolerance. What we tolerate is the range of acceptable values, right? So there you have the difference between the two. So this one is because of the measuring device. This one is set by the industry and it has to do with a bunch of factors. One of which is this. Scratch, scratch, right? Well, maybe as we do more examples, this will make more sense. Okay, there's some math involved here, quite a bit actually. Well, numbers, let's say. There's a lot of figuring out where the numbers go. Okay, this is all set by the province. And here, this is basically the meat and potatoes of today's lesson. Stating tolerance. You're gonna have to be able to state tolerance. And so you need to know four things. There's what we call the maximum, and watch what it is. The largest measurement acceptable. Minimum is the smallest measurement that is acceptable. What's the nominal? It's what we call the target. That's what we're aiming for. Ideally, you would want all parts to measure this. Okay? And then tolerance is the range / variation that is allowed. And this picture right here is what I always want you to imagine when you get one of these tolerance questions. That there is a cap on the high end, there's a cap on the low. Only parts that follow between here are acceptable. In this particular industry, we don't know, right? So there's the max, watch what it is. These formulas I made. So you got to kind of watch out. If this is your min and this is your max, right? If you want to go from this to the top, right, then you would just take min plus the tolerance, because the tolerance is this here. Again, let's make this clear. This is tolerance. So to go from here to there, right, you would just take whatever the minimum allowed is and you would add the tolerance to go up. And vice versa. If you want to go from here to the lowest possible value, you would just take the max and subtract the tolerance. If you want to know what that tolerance is, make sure you pay attention, right? If you want to know what this gap is, because depending on the industry, right, it might be small or big. It depends on what the industry is, right? So this gap could be really small or really big. It depends, okay? But you would just go max minus min. This one is perhaps. This is the formula for the definition of tolerance, right? It's the range or variation allowed. So if you go max minus min, that's the tolerance. Okay, let's put this to the test here. Before I do anything, guys, I'm going to stop right here. Pay attention, guys. These are the four standard ways of stating tolerance. These are four ways. The province wants you to know all four ways. So this would be study sheet entry. Some of my ACs have this, like, hey, state it like this, like this, like this, right? I show you kind of how to model it, but I would say take up a little bit of space on your study sheet and just have these on there, okay? So this is study sheet entry, right? Four ways to state tolerance. Okay. Study sheet. And basically what I'm going to do here is I'm going to show you each one. What does it look like in terms of the template, and what would that look like if we actually were to put numbers in for everything? Okay. Okay, here we go. If it's stated like this, look at they all actually look unique. But look at the half. See that half in front? That is a dead giveaway that it's this format, right? So let's rewrite this, shall we? Once you work with this, guys, it's supposed to say plus or minus. My bad. Something must have shifted when I copied it. Plus or minus half of 10. What's half of 10? I used an easy number for this one. Half of 10 is just 5 mLs, right? Okay. So I would suggest rewrite it like that when you're trying to fill in these four things. So I'm gonna state what is the maximum allowed mLs in this case. Well, guess what? We're gonna go 250 plus 5. That's 255 ml. Right? That's the maximum allowed in this industry. Let's say they're bottling juice, right? And so the maximum that is allowed is 255. The minimum that is allowed would be 250 minus 5. That'd be 245. What's the tolerance? Remember what I told you way up here? How do you get your tolerance? Subtract these two, and you'll recognize this number. But please just do it anyways, because later on there's some curveballs there. So this is 10 mLs, which lo and behold, you saw that here already, right? Which lo and behold is what we were told. Whatever's inside the brackets is the tolerance. But trust me, just do it. Stealing Nike's slogan, right? Nominal, right, would be this number up front here. That's what we aim for. Ideally, every single bottle should be 250 on, like right on 250. But we allow 251, 252, 253, 254, all the way up to 255. 256 would no longer be allowed. They would pull that from the line, right? And then maybe the worker just drinks it. I don't know what the policy is. But why am I doing this, guys? Because when you have all four, you can rewrite this tolerance in this format, in this format, in this format. You can do whatever you want once you have these four items kind of on the side. So that's what I'm practicing right now. Let's do it one more time for this format here. Watch this. You look at this, right? You're like, this is definitely a tolerance. Which one does this look like on my study sheet? There's a 0 here, okay, and there's a plus something else up top. Okay, so I'm looking at this format right here. Okay, I've identified that. To get the maximum temperature allowed, this is actually fairly easy. You go 5 plus whatever is here. So that's 7 degrees Celsius is the highest temperature that would be allowed. What's the minimum? 5 minus 0. I think you can handle that, right? 5 degrees Celsius is the lowest temperature allowed. What's my tolerance? Max minus min, right? Max minus min. You're like, Mr. Jackson, I can see it. I can see it that it's 2. Trust me, in a bit there's going to be a bit of a curveball. So if you do this every time, you don't have to guess. 2 degrees Celsius is the tolerance. So the difference between the highest and the lowest is only 2 degrees tolerance, right? Not a whole lot. The nominal, what do you think we would be aiming for if all you had is this? And the answer is, guys, the big number up front. We're aiming for this. And this particular industry, we're aiming for that. And later I'm going to highlight that. The nominal is that big number up front. Okay, next. Cover this for a bit, right? You're looking at this number. I just gave you this on a test, right? You're like, what do I do there? Well, let's go find it. It's plus 0 minus 1. Plus 0. Okay, plus 0 top minus something. So it's this one right here. So you've identified it, but really you don't need this to fill out these 4 things here. All you're going to do is, to get the max, is 45 plus 0. So the greatest width is 45 millimeters. The min is 45 minus 1. So you just follow that. You're with me, right? It's a little dry, I know. So basically I just followed this, plus minus. Plus to get the max, minus to get the min. Tolerance. Max minus min. There's only 1 millimeter. And watch, these get very small. Like sometimes it's like 0.01. That's all you have for tolerance, right? Have you ever seen fiber optic cable? Like they install that now in the houses, right? Bell. They installed it in my house, and the guy installing it, he's like, "You want to see it?" And it was like the width of your hair. That's a small little. That's the fiber optic cable. That's so much faster than the current internet, which is like a super thick cable, right? And so that thin cable, like there's not a whole lot of tolerance when they make those, right? What's the nominal here? What do you think is the nominal if you had to guess? 45, all right. Go buy a lottery ticket. I'm just kidding. No, yeah, that's right, guys. I wanted you to see the pattern. The big number, right? Big number up front, nominal. Big number up front, nominal. That's what we're aiming for. Here, 45, that's what we're aiming for. Next, this one. This one is the tricky one, so you got to pay attention here. You see two numbers, that's it, no plus minus, right? So you will see, oh, okay, this means that this is the max, this is the min. So let's just write that down. Boom, there's no plus, no minus. We just write it down. Tolerance is 15 minus 12. That's 3 centimeters. What's the nominal here? We don't know, right? You have two numbers. The province says that it's not critical to know the nominal here, but if they do ask, the nominal is like this. Max plus min brackets divided by 2. That's how you get your nominal here. What do you know this as? If you add two numbers and divide it by 2, what are you finding? Finding the average or the middle. Okay, so you're going to go 15 plus 12. Make sure you put that in brackets and divide that by 2. 15 and 12, 27 divided by 2, right? What is that? 13.5? 13.5 centimeters. So this is the only oddball where you have to do the average. Yeah. That's fine. Yeah. So I will tell you, if you see something, you see a pattern, and it works for you, do it. It's fine. But I'm sticking to my plan. Okay, I'm sticking to this method because I've taught this many, many times, and I have my plan and I stick with it. But I do know that there's many ways to get there. I do know that. Okay, and go for it. You have my permission. You have my blessing. You go with it. Okay. Okay. One thing that I want to highlight though, because imagine this is June. Can you imagine June is going to be just around the corner here? I want you to always highlight nominal and highlight it like that. The big number up front is always the nominal, except for the last one. We don't have a nominal right up front, so you need to do a little bit of work there. This is perhaps when you write this, if you write this on your study sheet, just say to find nominal, do this, right? I will to find nominal. We do this, which in turn gives us the nominal. Okay, that's the only time you have to do that. All the other three formats you don't have to worry about. So, Mr. Erickson, why would they do that? Why wouldn't they just agree on one way of stating tolerance? To be honest, I don't quite know. And it might be that you go to a different industry and they have a different format, but these are the four most common, right? So I always tell students, why would a company want to use this, for example, right? This format. Well, they kind of want to aim for the 5 degrees Celsius. It's okay to go a little bit over, but it's not okay to go lower, right? Like they're really picky on not going lower. So something would freeze, for example, right? Like if there's a, I'm thinking kombucha tea, I don't know, whatever, right? It needs to be at a certain temperature, or else you're messing with the culture that's inside, right? The bacteria. So maybe they would aim for this, right? Or landing strip. It has to be, 2 kilometers. It can't be shorter than that. Sure, you can go over if you want. If you have the room, sure, go for it, but you can't go lower than that. Um, when you're giving a dosage, a vaccine, you probably want to use this, right? 2 milliliters. Don't go over, because what happens if you go over? Can cause an overdose, right? Something can go really bad, right? If you go lower, it might not be as effective, right? But it's not life-threatening. So there is reasons why one chooses one over the other. In kitchencraft, we would have probably identified with this more. We're aiming for something. If it's a little over, a little under, that's fine. Just keep going, right? So, or maybe no, this one would not have been a kitchencraft. We had kind of like we all had our numbers that we aimed for. Like this is what we want. If you're over or under, we understand because the equipment doesn't always work, right? The way it's supposed to be. All right. So tolerance, guys, is what is acceptable, right? So it's different than what we've been doing so far. All right. Let's go back to 39. I want you to read this. I want you to take this tolerance here and fill in these 4 items here. Then I want you to use these 4 to rewrite that tolerance in this format. There's 1, 2, 3, 4 formats. Would I expect you to fill it in this format? It's already in that format, isn't it? This is already here. So in this case, you don't worry about that. It's already in that format. So I would expect you to fill it in these other 3. See if you can do it. So let's take a couple minutes right now. You're going to try this. You're going to try it and come up with these 4 and then rewrite it in these 3 formats. And I will be with you shortly. You do one right after me. Okay? I'm using nice and easy numbers for now. So 45, I'm just going to rewrite this quickly because I don't want the half in front of it. So that's really what this is saying, is a tolerance. So the max is 47, right? And the min is 43 millimeters, right? I'm going to show this work here. This would be 4 millimeters. And you're like, Mr. Dirksen was right there. Why do you bother? I have my reasons because later on you'll see what's going to happen later. But if you know what to do, you're good. The nominal is 45. Okay, so you've got these 4. This is what you need to rewrite it. So if you want it in this format, you go get the max and you get the min and you write it like that. You're done. You get a mark. So even if I don't ask you to do this, guys, I would strongly recommend you do this every time and then rewrite it. It's so much easier. Min, you take the 43, don't forget your units, minus 0 plus tolerance, which is, right, it asks for tolerance, which is 4 millimeters. And I put units everywhere so I don't lose marks. Okay? Then the max is 47, no big deal, plus 0 millimeters minus 4 millimeters. Bingo, you got 3 marks, 3 out of 3. All started with you compiling, doing a bit of an inventory on the side, because every single tolerance should be able to give you these pieces of information, right? For us to know what we're doing. Okay. Let's see here. Which one? So considering my tolerance, do you know which one helps me the most? Is this one right here. which one of these would actually be acceptable? Would 43.01, if I measure it, 43.01, would that be acceptable? It's higher than the lowest, right? So yes. 47.01? Nope. It's past the max, right? Even just by a little bit, it is not acceptable. I would still let it go, by the way. A kitchen crab, be like, yeah. But anyways, don't do that. For us, it's a no-no, right? 42.99. Nope. Even if it's small, but it's below the 43. I'll just say this, above 47, right? Below 43. 42.79? Nope. Anyways, that's it. Let's do another one before we go. Okay. Stay with me, guys. I know this is dry, but trust me, the old book, you would have all been sleeping by now. Anyways, use this. One of these 4 formats, I just went copy paste, right? One of these 4 is already taken care of by the one you have up here. So scratch that one. I want you to identify it. One of these you don't need to do. But take this, fill in this, and answer the bottom part as well once you've done your tolerance. I'll post the keys later. That was already done, right? That's okay. How are we doing? Yep. Oh, yeah. This is 120. Good catch. This is 120. Because it's max, right? Max goes in here. Plus 0 can't go higher, but you can go lower. This technically, this one wasn't necessary to do it again, but doesn't hurt, right? So you get one, you should be able to get it in the other formats, okay? And then answer the question below here. I'm gonna go with this one right here with my orange marker. So 109 would be a no-no. 110 would actually be still acceptable. 120 would also be acceptable. 121, no longer. It's already over. So if it's right on it, it's still acceptable. Okay. These ones get tricky. I have like 4 decimals going sometimes, and so you got to know your decimal places. You're done for today, right? I would be too. So this is what I'm going to tell you though, and I'm posting the keys. I don't know if you're trying it, right? But I'm posting keys. So I'm going to go 41 to 43. I'm going to go 41 to 43. I'm going to post that. I'm going to call that homework. So be ready for tolerance tomorrow.